Hello aspirants, welcome to Magic World of Physics. In this video, we're going to discuss about some questions from classical mechanics part which is asked in various exams like GATE, BARC, CHESS, TIFR. Hope this video will be helpful for your coming BARC exam 2026. Without any further delay, let's get started. So the first question is two coupled oscillator in a potential V is equal to half k x square plus 2xy plus half k y square can be decoupled into two independent harmonic oscillator by means of an appropriate transformation x dash y dash is equal to s into xy. The transformation matrix S is dash. So here V is equal to half k x square plus 2xy plus half k y square. This is equal to half into kx square plus ky square plus 4xy. This is equal to half into kx square plus ky square plus 2xy plus 2yx. So the V matrix can be written as k2 2k and V minus lambda I is equal to k minus lambda 2 2 k minus lambda is equal to 0. That is k minus lambda the whole square minus 4 is equal to 0. That is k minus lambda is equal to plus or minus 2. That is lambda 1 is equal to k minus 2 and lambda 2 is equal to k plus 2. And the x matrix is xy. And to find the eigenvector, we need to calculate v minus lambda 1 into I into x is equal to 0. That is k minus 2 2 k minus 2 xy is equal to 0. That is 2 2 2 2 xy is equal to 0 0. That is 2x plus 2y is equal to 0. That is minus x is equal to y. That is v1 is equal to minus 1 and 1. To find the normalized form of v1, that is 1 by square root over minus 1 the whole square plus 1 square into matrix minus 1 1. That is 1 by square root over 2 into minus 1 1. Then for lambda 2 is equal to k plus 2, we need to find v minus lambda 2 into I into x is equal to 0. That is k minus k plus 2 2 2 k minus k plus 2 into the matrix x by which is equal to 0. That is equal to matrix minus 2 2 2 minus 2 xy matrix is equal to 0. That is minus 2x plus 2y is equal to 0. That is x is equal to y. Therefore v2 is equal to 1 1. To find the normalized form, that is v2 is equal to 1 by square root over 2 into 1 1. So the transformation matrix S is the combination of v1 and v2. So this can be right as that is S is equal to 1 by square root over 2 into minus 1 1 1 1, or it can also be written as S is equal to 1 by square root over 2 into 1 minus 1 1 1. This is the answer. The next question is the velocity of a particle moving in one dimension is given by v is equal to v0 sine pi x by x0, where v0 and x0 are positive constants of appropriate dimensions. If the particle is initially at x by x0 is equal to epsilon, where epsilon less than 1, then in the long time it dash. So we need to find the correct option. Here it is given that v is equal to v0 sine pi x by x0. That is v is equal to dx by dt, which is equal to v0 sine pi x by x0. Rearranging this and integrating, we get integral over dx by sine pi x by x0 is equal to integral over dt. It is given that initially, that is at t is equal to 0, x by x0 is epsilon. That is, by after integrating, we can write it as ln over tan pi x by 2x0 is equal to t plus c. This is equation number 1. And applying the boundary condition, that is at t is equal to 0, x by x0 is equal to epsilon, we get it as ln over tan pi epsilon by 2 is equal to c. And we know that epsilon is very less than 1, so that tan epsilon can be written as epsilon. That is ln over pi epsilon by 2 is equal to c. This is equation number 2. Substituting the value of 2 in 1, we get ln over tan pi x by 2 x0 is equal to t plus ln over pi epsilon by 2. That is ln over tan pi x by 2 x0 divided by pi epsilon by 2 is equal to t. That is tan of pi x by 2 x0 is equal to pi epsilon by 2 into e raised to t. Here it is asking about for a long time. So we are taking the value of t tends to infinity. So when t tends to infinity, this equation changes as pi x by 2 x0 is equal to tan inverse of pi epsilon by 2 into e raised to infinity. That is pi x by 2 x0 is equal to tan inverse of infinity. We know that tan inverse of infinity is equal to pi by 2. That is pi by 2 x by x0 is equal to pi by 2. That is x is equal to x naught. Then we need to find the value of velocity at x is equal to x naught. That is v is equal to v naught sine pi x0 by x0, which is equal to 0. That is here velocity is equal to 0. So there is no acceleration here. That is here there is no oscillatory motion. So that the first option is wrong. And the option D is also wrong because it says that it executes the oscillatory motion. So that it is wrong. From here, we understood that for t tends to infinity, that is for a long time, the value of x is x0. So the correct option is it tends towards x is equal to x0. So the option C is the right answer. The next question is, a pendulum executes small oscillations between the angle theta 0 and minus theta 0 if tau of theta d theta is the time spent between theta and theta plus d theta, then tau of theta is best represented by dash. So here we need to find the correct graph. So here it is asking about a pendulum. So we know that for a pendulum at the mean position, that is at x is equal to 0, the potential energy is 0 and the kinetic energy is maximum. That the time is minimum here at the mean position. Then at the extreme position, that is at x is equal to a and x is equal to minus a, the potential energy is maximum and the kinetic energy is minimum, and there the time is maximum. Here we need to find the time spent between theta and theta plus d theta. So we assume that if the bob is moving from the mean position to the extreme position, it is making an angle theta and it is covering a distance x. For small angular displacement, it covers only a small distance, that let's say it is dx. So here we need to find the probability of finding the bob within x and x plus dx. So to find this probability, it is equal to the time taken to go through this dx distance divided by the total time period. That is, here we know that to complete one oscillation, it covers the dx distance 2 times. That is, it covers the time taken to cover the dx distance 2 times is 2 dt. So the probability can be written as 2 dt divided by the time period, that is 2 pi by omega. That is 2 dt by 2 pi by omega. This can be rewritten as omega dt by pi. And for simple harmonic oscillator, x is equal to a sine omega t, that is velocity v is equal to dx by dt, that is a cos omega t into omega, that is a omega into square root over 1 minus sine square omega t, that is omega into square root over a square minus a square omega square sine square omega t, that is omega into square root over a square minus x square, because we know that x is equal to a sine omega t. So from here we get the value of velocity. Now the time dt is equal to dx by v, because time is equal to distance by velocity. So that dt is equal to dx by v, that is dx divided by omega square root over a square minus x square. So the probability p of x dx is equal to omega dt by pi, that is equal to omega dx divided by omega square root over a square minus x square into pi. That is p of x is equal to 1 by pi square root over a square minus x square. So this is the probability. So this value of will be maximum at x is equal to plus or minus a. That is at x is equal to plus or minus a, this probability tends to infinity, and at x is equal to 0 it is minimum. That is the value of probability at x is equal to 0 is 1 by pi a. That is at x is equal to 0, probability not equal to 0 and at x is equal to plus or minus a, that is at x is equal to plus or minus theta 0, the probability tends to infinity. So we need to select a graph that satisfy these two conditions. So at first option, in this a option, it is given that at x is equal to 0, the probability is 0, but here we know that at x is equal to 0, the probability is not equal to 0. So the option A is wrong. Coming to B option, at x is equal to 0, here the probability not equal to 0, and at the x is equal to plus or minus theta 0, we get the probability tends to infinity. So the right option is option B. Next question is, the acceleration due to gravity on the surface of Earth is approximately 2.6 times that on the surface of Mars. Given that the radius of Mars is about 1/2 the radius of Earth, the ratio of the escape velocity on Earth to that on the Mars is approximately dash. So here it is asking about the escape velocity, that is escape velocity is equal to square root over 2gr. That is escape velocity of Earth divided by escape velocity of Mars is equal to square root over GERE divided by GMRM. Here it is given that RE by RM is equal to 2 and GE by GM is equal to 2.6. So that we get the answer as 2.3. Question is, two particles of identical mass moving in a circular orbit under central potential V is equal to half k r square. Let L1 and L2 be the angular momentum and R1 and R2 be the radius of the orbits respectively. If L1 by L2 is 2, then what is the value of R1 by R2? So here V is given, that is half k r square. So V effective is equal to L square by 2m r square plus half k r square, where L is the angular momentum. So here it is asking about the circular orbit. So for circular orbit, dou V effective by dou r is equal to 0. This is the condition. So differentiating V effective, we get minus L square by mr cube plus kr is equal to 0. So that is L square is proportional to r raised to 4. That is L is proportional to r square. So that we can write L1 by L2 is equal to R1 by R to the whole square. That is R1 by R2 is equal to square root over L1 by L2. And we know that L1 by L2 is equal to 2. So that R1 by R2 is equal to square root over 2. So this is the answer. The next question is, the radius of the Earth is approximately 6400 km. The height h at which the acceleration due to Earth gravity differs from g at the Earth's surface by approximately 1% is dash. So here it is asking about the height. So we know that g by g dash is equal to 1 plus 2h by r, because here g dash is the acceleration to gravity at the height. So g by g dash is equal to 1 plus 2h by r. This is equation number 1. And g by g dash is minus 1 is equal to 2h by r. That is g by g dash is equal to 2h by r. That is g minus g dash by g into g by g dash is equal to 2h by r. That is equation number 2. So substituting the value of 1 in 2, we get g minus g dash by g into 1 plus 2h by r, which is equal to 2h by r. And we know that g minus g dash by g is 1 by 100, because it is given in the question itself. So that 1 by 100 into 1 plus 2h by r is equal to 2h by r. That is 1 by 100 is equal to 1 by r by 2h plus 1. That is equal to 1 by 100 is equal to 1 by 6400 by 2h plus 1. Solving this, we get h is equal to 32.32 km. The next question is, which of the following figures best represent the trajectory of a particle moving in a repulsive central potential V is equal to a by r. So we need to find the graph. Actually, this is the same case of the Rutherford scattering. We know that in Rutherford scattering, the alpha particle is coming towards the nucleus. As alpha particle and nucleus have the same charge, it will repel each other as the alpha particle moves towards the nucleus. So due to the repulsive nature, the option B and option D is wrong. And we know that due to the repulsive nature, the alpha particle comes towards the nucleus, can't cross the nucleus. So the option A is also wrong, because in the option A it is given that the curve is crossing from the negative side to the positive side. This is not possible. So the option C is the right answer. Next question is, consider a set of particles which interact by a pair potential V is equal to A r raised to 6, where r is the interparticle separation and a greater than 0 is a constant. If a system of such particles has reached virial equilibrium, then what is the ratio of kinetic energy to the total energy of the system? So here V is equal to A r raised to 6. This is in the form of A r raised to n plus 1. That is, here n plus 1 is equal to 6, that is n is equal to 5. And we know that T is equal to n plus 1 by 2 into V. That is 5 plus 1 by 2 into V, which is equal to 3V. And we know that total energy E is equal to kinetic energy plus potential energy, that is T plus V. That is equal to, T is equal to 3V, that is 3V plus V, which is equal to 4V. So we know that V is equal to T by 3. So substituting this here, we get E as 4 into T by 3. That is T by E is equal to 3 by 4. So the answer is 3 by 4. The next question is, assume that the Earth revolves in a circular orbit around the Sun. Suppose the gravitational constant g varies slowly as a function of time. In particular, it decreases to half its initial value in the course of 1 million years. Then during this time, the dash. So here we need to find the which option is correct. So here the Earth is revolving around the Sun, and at the initial time t naught, the gravitational constant is g1, and it is mentioned that after a time the gravitational constant reduces by half, so that g2 is equal to g1 by 2. And here no external force is present, so that the angular momentum L is constant. So the option C is wrong, because the option C says that the orbital angular momentum will increase. But here there is no external force, so the L is constant. So the option C is wrong. And we know that the energy E is equal to half m r dot square plus L square by 2m r square minus g of t mm by r. Here we write g of t because it is mentioned that the gravitational constant is a function of time. Here, that means here g is not a constant. This implies that E is also not a constant. That is dou E by dou T not equal to 0. So we can say that option B is also wrong, because the total energy not equal to 0, because it is mentioned that here the gravitational constant is changing with respect to time. So here the gravitational constant is not a constant, so that E is not a constant. So the option B is also wrong. Then for circular orbit, we know that V effective is equal to L square by 2m r square minus g of t mm by r. That is dou V by dou r is equal to minus L square by m r cube plus g mm by r square is equal to 0. That is L square by m r cube is equal to g mm by r square. That is L square by m r is equal to g mm. That is r is equal to L square by g m square. That is, here the radius is changing with respect to the gravitational constant g. That is r, that is the radius is proportional to 1 by g. So the option D is also wrong, because the option D says that the radius is same, but the radius is not same. So the option D is wrong. And from here we can write R2 by R1 is equal to G1 by G2, as R is proportional to 1 by G. So that G1 by G2 is equal to G1 by G2 is, we know, G1 by 2. So that this is equal to 2. That is R2 by R1 is equal to 2. So the correct option is A, because the radius of the Earth orbit will increase by a factor of 2. That is R2 by R1 is equal to 2. The next question is, a planet of mass m moves in the inverse square central field of the sun of mass m if the semi-major and semi-minor axes of the orbit are A and B respectively, then the total energy of the planet is dash. So here it is asking about the total energy. So here a planet of small m is moving around the sun of capital M. So here it is mentioned that the semi-major axis and the semi-minor axis as A and B respectively. So here by the conservation of angular momentum we can write L is equal to mv1a which is equal to mv2b, that is v1 is equal to v2b by a. Then by conservation of energy E is equal to half m v1 square minus gmm by a which is equal to half m v2 square minus gmm by b, that is half m b1 square minus v2 square is equal to gmm into 1 by a minus 1 by b, that is m by 2 into v2 square b square by a square minus v2 square is equal to gmm into b minus a by ab, that is m v2 square by 2 into b square minus a square by a square which is equal to gmm into b minus a by ab, that is v2 square by 2 into b plus a by a which is equal to gm by b, that is v2 square is equal to 2gma by b into b plus a. So that the energy is equal to half m into 2gma by b into b plus a minus gmm by b, that is gmma by b into b plus a minus gmm by b, that is equal to gmm by b into a minus b minus a by b plus a equal to minus gmm by a plus b. So this is the answer. Next question is, a planet of mass m moves in the gravitational field of the sun if the semi-major and semi-minor axes of the orbit are a and b respectively. The angular momentum of the planet is dash. So here a planet of mass m is moving around the sun of mass capital M. The planet is having the velocity v1 at A and it is having the velocity v2 at B. So by the conservation of energy, half m v1 square minus g mm by a is equal to half m v2 square minus g mm by b. This is equation number 1. Then by the conservation of angular momentum, m v1a is equal to m v2b, that is v1 is equal to v2b by a. This is equation number 2. Substituting the value of 2 in equation number 1, we get half m into v2 square into b square by a square is equal to minus gmm by a is equal to half m v2 square minus gmm by b, that is half m v2 square into b square by a square minus 1 is equal to gmm into 1 by a minus 1 by b, that is v2 square by 2 into b square minus a square by a square is equal to gm into b minus a by ab, that is v2 square by 2 into b plus a by a is equal to gm by b, that is v2 is equal to square root over 2gma by b into b plus a, and we know that L is equal to m v2b which is equal to m v1a which is equal to m into square root over 2gma by b into b plus a into b which is equal to square root over 2gma b square m square by b into b plus a. This is equal to square root over 2gm m square ab by a plus b. So the next question is, a planet of mass m and the angular momentum L moves in a circular orbit in a potential V is equal to minus k by r, where k is a constant. If it is slightly perturbed radially, the angular frequency of radial oscillation is dash. So that we need to find the value of angular frequency. So V effective is equal to L square by 2m r square minus k by r. So for circular orbit, dou V effective by dou r is equal to minus L square by mr cube plus k by r square is equal to 0. That is L square by mr cube is equal to k by r square. That is r is equal to L square by mk which is equal to r0. If it is slightly perturbed, means the circular orbit is changing to elliptical orbit. That is dou square V effective by dou r square at r equal to r naught is equal to 3L square by mr0 raised to 4 minus 2k by r0 raised to 3. That is equal to 3L square m raised to 4 k raised to 4 by m L raised to 8 is equal to minus 2k m cube by L raised to 6. That is equal to m cube k raised to 4 by L raised to 6 greater than 0. So this is a SCP point. So omega is equal to, as it is the elliptical orbit, here the omega angular frequency is equal to square root over dou square v by dou r square at r equal to r0 divided by m. That is equal to square root over m cube k raised to 4 by l raised to 6 by m is equal to mk square by l cube. So this is the answer. So the next question is, the probe Mangalyaan was sent recently to explore the planet Mars. The interplanetary part of the trajectory is approximately a half eclipse with the Earth, Sun and Mars at the time the probe reaches the destination, forming the major axis. Assuming that the orbits of Earth and Mars are approximately circular with radii RE and RM respectively, the velocity of the probe during its voyage when it is at a distance r from the Sun, neglecting the effect of Earth and Mars, is dash. So from the figure we can write 2a is equal to RE plus RM, and we know that E is equal to minus k by 2a, that is equal to minus gmm by 2a for the ellipse. And we know that energy E is equal to kinetic energy plus potential energy. So energy minus gmm by 2a is equal to half mv square minus gmm by r, that is minus gmm by re plus rm is equal to half mv square minus gmm by r, that is half mv square is equal to gmm by r minus gmm by re plus rm, that is v square is equal to 2gm by r minus 2gm by re plus rm, that is v square is equal to 2gm into re plus rm minus r divided by re plus rm into r, that is v is equal to square root over 2gm into re plus rm minus r divided by re plus rm into r. So this is the answer. So the next question is, consider circular orbit in the central force potential V is equal to minus k by r raised to n, where k greater than 0 and 0 less than n less than 2 if the time period of a circular orbit of radius r is t1 and that of radius 2r is t2, then t1 by t2 is dash. So here V is equal to minus k by r raised to n. So V effective is equal to L square by 2mr square minus k by r raised to n. And we know that r1 is equal to r and r2 is equal to 2r. So for circular orbit, dou V effective by dou r at r0 is equal to 0. That is minus L square by mr0 cube plus nk by r0 raised to n plus 1 is equal to 0. That is L square by mr0 cube is equal to nk by r0 raised to n plus 1. This is equation number 1. Then for circular orbit, L is equal to mr square theta dot, that is equal to mr0 square omega. This is equation number 2. Substituting the value of 2 in 1, we get mr0 square omega the whole square divided by mr0 cube is equal to nk by r0 raised to n plus 1. That is m square r0 raised to 4 omega square by m r0 cube is equal to nk by r0 raised to n plus 1. That is omega square is equal to nk by m r0 raised to n plus 2. That is equal to 4 pi the whole square by t square, that is t square is proportional to r0 raised to n plus 2, that is t is proportional to r0 raised to n plus 2 by 2, that is t is proportional to r0 raised to n plus 1 plus n by 2, that is t2 by t1 is equal to r2 by r1 the whole raised to 1 plus n by 2, that is t2 by t1 is equal to 2r by r the whole raised to 1 plus n by 2, that is which is equal to 2 the whole raised to 1 plus n by 2. So this is the answer. The next question is, a particle of mass m moves in a central potential V is equal to minus k by r in an elliptical orbit r is equal to a into 1 minus e square by 1 plus e cos theta, where 0 less than theta less than 2 pi and E denote the semi-major axis and eccentricity respectively. If its total energy E is equal to minus k by 2a, then the maximum kinetic energy is dash. So here we need to find the kinetic energy. Here it is given that V of r is equal to minus k by r and r of theta is equal to a into 1 minus e square divided by 1 plus e cos theta, and E is equal to minus k by 2a. E is equal to t plus v, and that T is equal to E minus B, which is equal to minus K by 2A plus K by R. That is T is equal to minus K by 2A plus K into 1 plus E cos theta divided by A into 1 minus E square. That is T max is equal to minus K by 2A plus K into 1 plus E divided by A into 1 plus E into 1 minus E, because when T equal to T max, the maximum value of cos theta is equal to 1. So that here we taken the value of cos theta as 1. So that T max is equal to minus K by 2A plus K by A into 1 minus E. That is K plus 2A into minus 1 plus 2 by 1 minus E, which is equal to K by 2A into minus 1 plus E plus 2 by 1 minus E, which is equal to K by 2A into 1 plus E divided by 1 minus E. That is minus K by 2A into E plus 1 by E minus 1, which is equal to E into E plus 1 divided by E minus 1. So this is the answer. The next question is, in the attractive Kepler problem described by the central potential V is equal to minus K by R, a particle of mass m with a non-zero angular momentum can never reach the center due to the centrifugal barrier. If we modify the potential to V of R is equal to minus K by R minus beta by R cube, one finds that there is a critical value of angular momentum Lc below which there is no centrifugal barrier. This value of Lc is dash. And here it is mentioned that the particle never reaches the center because R, so that we can write the R not equal to 0. So V effective is equal to L square by 2m R square minus K by R. Then dou V effective by dou R is equal to L square by m R cube plus K by R square is equal to 0. So that R naught is equal to L square by mk. That is not equal to 0. So that we had said that the particle can't reach the center because R not equal to 0. So if V effective is equal to L square by 2m R square minus K by R minus beta by R cube, that is here the V is modified, and if this is the new V effective, we can write dou V effective by dou R is equal to minus L square by m R cube plus K by R plus 3 beta by R raised to 4 is equal to 0. Multiplying R raised to 4, we get it as minus L square R plus Km R square plus 3 beta m is equal to 0. And here R is equal to L square plus or minus square root over L raised to 4 minus 4km square into 3 beta by 2km. That is L square plus or minus square root over L raised to 4 minus 12km square beta divided by 2km. So that R max is equal to L square plus square root over L raised to 4 minus 12km square beta divided by 2km. Then R minimum is equal to L square minus square root over L raised to 4 minus 12km square beta divided by 2km. So here we understood that R minimum is not equal to 0 and imaginary. So L raised to 4 greater than 12k m square beta. So if L is equal to 12k m square beta the whole raised to 1 by 4, we can say that R not equal to 0. So for R not equal to 0, LC is equal to 12k m square beta the whole raised to 1 by 4. The next question is, a spacecraft of mass m is equal to 1000 kg has a fully reflecting sail that is oriented perpendicular to the direction of sun. The sun radiates 10 power 26 watt and has a mass m is equal to 10 power 30 kg. Ignoring the effects of the planet or the gravitational pull of the sun to balance the radiation pressure on the sail, the area of the sail will be dash. Here it is given that m is equal to 10 power 3 kg and capital M is equal to 10 power 30 kg and P is equal to 10 power 26 watt. So the radiation pressure for the fully reflecting surface is equal to 2I by C, where I is the intensity, that is equal to P by A, that is equal to P by 4 pi R square. So the radiation pressure is equal to 2P by 4 pi R square C. So the gravitation pull is equal to Gmm by R square. This is equation number 1. And F is equal to P dot A, which is equal to 2Pa by 4 pi R square C. This is equal to Pa by 2 pi R square C. This is equation number 2. So 1 and 2 implies that Gmm by R square is equal to Pa by 2 pi R square C. That is A is equal to Gmm into 2 pi c by p. That is equal to, substituting all these values, we get 6.67 into 10 power minus 11 into 10 power 30 into 10 power 3 into 2 pi into 3 into 10 power 8 divided by 10 power 26, which is equal to 1.25 into 10 power 6. So the option D is the right answer. The next question is, a particle thrown with the speed v from the Earth's surface attains a maximum height h. If v is the half the escape velocity and r denotes the radius of Earth, then h by r is dash. So here r is the radius of Earth and m is the mass of the Earth, and a particle of mass small m and a velocity v is thrown from Earth from a height h. So, by the conservation of energy, the energy at B is equal to energy at C, and we know that at C there is no kinetic energy, only potential energy present. So so we can write it as half m v square minus g mm by r. This is the energy at B. Then the energy at C is that is, this is equal to, energy at B is equal to energy at C. That is, this term is equal to minus g mm by r plus h. So, and here it is mentioned that v is the half of the escape velocity. So we know that the escape velocity is square root over 2gm by r. So half of escape velocity means v is equal to half into square root over 2gm by r. So substituting these values, we get half m into 1 plus 1 by 4 into 2gm by r minus gmm by r is equal to minus gmm by r plus h. That is, 1 by 4r minus 1 by r is equal to minus 1 by r plus h. That is, minus 3r by 4r square is equal to minus 1 by r plus h. That is, minus 3 by 4r equal to minus 1 by r plus h. Rearranging this, we get 3 into r plus h is equal to 4r. That is, 3r plus 3h is equal to 4r. That is, 3h is equal to r. This implies that h by r is equal to 1 by 3. So the answer is 1 by 3. The next question is, a particle in 2 dimension is found to trace an orbit r is equal to r0 theta square if it is moving under the influence of central potential v is equal to c1 r raised to minus a plus c2 r raised to minus b, where r0, c1, c2 are the constant of appropriate dimension. The values of a and b respectively are dash. So here it is given r is equal to r0 theta square and v is equal to c1 r raised to minus a plus c2 r raised to minus b. So the differential equation of the orbit is d square u by d theta square plus u is equal to minus m by l square u square into f of 1 by u. And we know u is equal to 1 by r, that is u is equal to 1 by r0 theta raised to minus 2. That is, du by d theta is equal to 1 by r0 into minus 2 into theta raised to minus 3. That is, d square u by d theta square is equal to 1 by r0 into minus 2 into minus 3 into theta raised to minus 4. This is equal to 1 by r0 6 theta raised to minus 4. That is equal to 6 by r0 into theta raised to minus 2 the whole square. That is equal to 6 theta raised to minus 2 u, which is equal to 6u by theta square. So substituting all these values in equation number 1, we get 6 by r0 theta raised to 4 plus 1 by r0 theta square is equal to minus m r0 square theta raised to 4 f of r by l square. And this implies f of 1 by u is equal to minus 6 l square by m r0 cube theta raised to 8 minus l square by m r0 cube theta raised to 6. And we can substitute a is equal to 6l square r0 by m and b is equal to l square by m. So that f of r is equal to minus a r raised to minus 4 minus b r raised to minus 3. So v of r is equal to minus integral over f of r dr, that is equal to integral over a r raised to minus 4 plus b r raised to minus 3 into dr. That is, a r raised to minus 4 plus 1 by minus 3 plus b r raised to minus 3 plus 1 by minus 3 plus 1. That is, a by minus 3 r raised to minus 3 plus b r raised to minus 2 by minus 2, which is equal to c1 r raised to minus 2. Sorry, c1 r raised to minus 3 plus c2 r raised to minus 2. That is, c1 r raised to minus a plus c2 r raised to minus b. So that a is equal to 3 and b is equal to 2. So the answer is this. That is, a equal to 3 and b is equal to 2. The next question is, a satellite of mass m orbits around Earth in an elliptically trajectory of semi-major axis A at a radial distance r is equal to r0 measured from the center of the earth, the kinetic energy is equal to half the magnitude of total energy. If capital M denotes the mass of earth and the total energy is minus gmm by 2a, the value of r0 by a is nearest to dash. So for a satellite, we know that the total energy by 2 is the kinetic energy. That is, total energy is equal to minus gmm by 2a. So kinetic energy is equal to gmm by 4a. That is, potential energy is equal to kinetic energy minus total energy minus kinetic energy. That is equal to minus gmm by 2a minus gmm by 4a. That is equal to minus 3 gmm by 4a. And at r equal to r naught, the potential energy is equal to minus gmm by r0. Equating these two values of potential energy, we get minus 3 gmm by 4a is equal to minus gmm by r0. That is, 3 by 4a is equal to 1 by r0. That is, r0 by a is equal to 4 by 3. This is equal to 1.33. So this is the answer. The next question is, an annulus of mass m made of a material of uniform density has inner and outer radii a and b respectively. Its principal moment of inertia along the axis of symmetry perpendicular to the plane of annulus is dash. So here the moment of inertia of annulus is IB minus IA. Then area of annulus is pi b square minus pi a square, which is equal to pi into b square minus a square. Then total mass m is equal to sigma a annulus, that is equal to sigma pi b square minus a square, that is equal to sigma is equal to m divided by pi b square minus a square. And the mass of disk of radius b mb is equal to sigma into pi b square, that is equal to m divided by pi b square minus a square into pi b square. This is equal to mb square by b square minus a square. Then the mass of a disk of radius a, we get ma is equal to sigma into pi a square, that is equal to m divided by pi into b square minus a square into pi a square, that is equal to ma square divided by b square minus a square. Then ib is equal to half mb into b square, that is equal to half into mb square divided by b square minus a square, that into b square, that is equal to half into mb raised to 4 by b square minus a square. Then ia is equal to half ma into a square, that is half m a square by b square minus a square into b square is equal to half ma raised to 4 by b square minus a square. I annulus is equal to ib minus ia, that is equal to half mb raised to 4 by b square minus a square minus half m a raised to 4 by b square minus a square, that is equal to half m b raised to 4 minus a raised to 4 divided by b square minus a square. We know that b raised to 4 minus a raised to 4 is equal to b square minus a square into b square plus a square. Then I annulus is equal to half m into b square minus a square into b square plus a square divided by b square minus a square, that is equal to half m into b square plus a square. So this is the answer. The next question is, two bodies of equal mass m are connected by a massless rigid rod of length L lying in the xy plane with the center of the rod at the origin. If this system is rotating about the z axis with the frequency omega, then its angular momentum is dash. So here it is asking about the angular momentum. Here the axis of rotation is passing through the center, rotating about z axis. So here the I is equal to I1 plus I2, that is m into L by 2 the whole square plus m into L by 2 the whole square, that is 2ml square by 4, that is equal to ml square by 2. Moment of inertia is ml square by 2. Then L is equal to I omega, that is ml square by 2 into omega. So this is the answer. Next question is, a pendulum consists of a ring of mass m and radius r suspended by a massless rigid rod of length L attached to its rim. When the pendulum oscillates in the plane of ring, then the time period of the oscillation is dash. This question can be solved in two methods. The first method is, here it is mentioned that the pendulum is having a mass m and the radius, let it be r, and the length be L. And at the topmost point we consider that the potential energy is 0. And we know that the time period of a pendulum is 2 pi into square root over L by G. That is, multiplying m by ml on numerator and denominator, we can write it as T is equal to 2 pi into square root over L by G into M by L into L by M. That is 2 pi into square root over I by MGL, because I is equal to ML square. So here we know that D is equal to R plus L. So here the time period is equal to 2 pi into square root over IA by MGL. Here IA is, as the ring, as this rotates and it translates, we can say that here the moment of inertia at the point A is ICM plus MD square, that is MR square plus M into L plus R the whole square, that is M into 2R square plus L square plus 2LR. That is T is equal to 2 pi into square root over M into 2R square plus L square plus 2LR divided by mg into L plus R. That is equal to 2 pi into square root over 2R square plus L square plus 2LR divided by G into L plus R. So if in this equation, if R is equal to 0, we get our normal time period, that is T is equal to 2 pi square root over L by G. So in this way we can solve the answer. So this is the first method. Then moving to the second method. We know that in the polar coordinates, velocity is equal to r dot r cap plus r theta dot theta cap. And here r is equal to d, that is r dot is d dot, that is equal to 0. That is v is equal to d theta dot theta cap. And we know L is equal to half I theta dot square plus half M d square theta dot square plus mg d cos theta. Here the first term is the rotational energy term and the second term is the translational kinetic energy term. Here the theta is the generalized coordinate. So the Lagrangian equation of motion can be written as d by dt of dou L by dou theta dot minus dou L by dou theta dot is equal to 0. That is m into r square plus d square into theta double dot plus mgd sin theta is equal to 0. That is theta double dot plus gd by r square plus d square theta is equal to 0. That is omega is equal to square root over gd by r square plus d square. That is t is equal to 2 pi by omega, that is 2 pi into square root over r square plus d square by gd. And we know that d is equal to L plus R, that is t is equal to 2 pi into square root over r square plus L plus R the whole square divided by g into L plus R. That is 2 pi into square root over 2r square plus L square plus 2RL divided by g into L plus R. So in this way also we can solve the question. The next question is, two masses m each are placed at the points x comma y is equal to a comma a and minus a comma minus a, and two masses 2m each are placed at the points a comma minus a and minus a comma a. The principal moment of inertia of the system are dash. So here we have given 2m 2 times and m mass 2 times, and their coordinates are also given. So here Ixs is equal to summation over mi into yi square plus zi square, which is equal to summation over mi yi square, because here zi is equal to 0. So this is equal to 2ma square plus ma square plus 2ma square plus ma square, which is equal to 6ma square. So for Iyy, this is equal to summation over mi xi square plus zi square, that is equal to summation over mi xi square. This is also 6ma square. Then Ixy is equal to minus summation mi xi yi. This is equal to minus of ma square minus 2ma square plus ma square minus 2ma square is equal to 2ma square. Similarly, Iyx is equal to minus summation mi yi xi, this is equal to 2ma square, and Ixz is equal to minus summation mi xi zi, which is equal to 0. Iyz is equal to minus summation mi yi zi, this is equal to 0. Izx is equal to minus summation mi zi xi, this is equal to 0. Izy is equal to minus summation mi zi yi, this is equal to 0. Then Izz is equal to summation over mi into xi square plus yi square, that is 2m into a square plus m into 2a square plus 2m into 2a square plus m into 2a square, that is 4ma square plus 4ma square plus 2ma square plus 2ma square, that is equal to 12ma square. So the inertia tensor can be written as 6ma square, 2ma square, 0, 2ma square, 6ma square, 0, 0, 0, 12ma square. That is inertia tensor minus lambda I is equal to 0. That is 6ma square minus I, 2ma square, 0, 2ma square, 6ma square minus I, 0, 0, 0, 12ma square minus I, which is equal to 0. Solving this, we get 12ma square minus I into 6ma square minus I the whole square minus 2ma square the whole square is equal to 0. From here, we get 12ma square minus I into 8ma square minus I into 4ma square minus I is equal to 0. That is, I is equal to 4ma square, 8ma square and 12ma square. So, these are the values of I. So from here we can find the principal moment of inertia of the system are 4ma square, 8ma square and 12ma square. The next question is, a rod pivoted at 1 and is rotating clockwise 25 times a second in a plane. A video camera which records at the rate of 30 frames per second is used to film the motion. To someone watching the video, the apparent motion of the rod will seem to be dash. Here we need to find the value of apparent frequency, that is F apparent is equal to F rotation minus N frame. We know that F frame is F camera and F rod is F rotation. So F apparent is equal to F rod minus NF camera. Here F rod is equal to 25 RPS and it is clockwise. F camera is 30 FPS and N is an integer that should make N F frame and F rod close. So if we put the value of N as 0, then NF camera becomes 0 and F rod is 25. 0 and 25 is not the close values. The difference between them is very high. So we can't take the value of N as 0. If we take the value of N as 1, then F camera equal to 0 and F rod is equal to 25. Then the difference becomes only 5. So that it is very close numbers. Then if we take the value of N is equal to 2, then F camera becomes 60 and F rod becomes 25. This is also not close values because the difference is very high. So we take the N as 1. So the F apparent is equal to 25 minus 30, which is equal to 5 RPS. The apparent motion is always in the opposite direction of actual rotation. So here the rod is rotating clockwise. So we can say that the apparent motion is in the anti-clockwise direction. So the right answer is option D because the F apparent value is 5 rotation per second and it is in the anti-clockwise direction. The next question is, two events separated by a spatial distance 9 into 10 power 9 meter are simultaneously in one inertial frame. Then the time interval between two events in a frame moving with a constant speed 0.8 c is dash. So here in S frame, T2 minus T1 is equal to 0 and X2 minus X1 is equal to 9 into 10 power 9 and V is equal to 0.8 c. Here we need to find the T2 dash minus T1 dash, that is in the S dash frame. So T2 dash minus T1 dash is equal to T2 minus T1 divided by square root over 1 minus V square by C square minus V by C square into X2 minus X1 divided by square root over 1 minus V square by C square. This is equal to minus V by C square into X2 minus X1 divided by square root over 1 minus V square by C square because T2 minus T1 is equal to 0. So this is equal to minus 9 into 10 power 9 V by C square into 1 by square root over 1 minus 0.8 c square by c square. That is T2 dash minus T1 dash is equal to minus 40 seconds. That is T2 dash minus T1 dash is equal to 40 seconds. So the next question is, an inertial observer sees two events E1 and E2 happening at the same location but 6 microseconds apart in time. Another observer moving with a constant velocity v sees the same events to be 9 microseconds apart. The spatial distance between these events as measured by the second observer is approximately dash. So here x2 minus x1 is equal to 0 and t2 minus t1 is equal to 6 into 10 power minus 6 and t2 dash minus t1 dash is equal to 9 into 10 power minus 6. So this is equal to t2 minus t1 divided by square root over 1 minus v square by c square minus v by c square into x2 minus x1 divided by square root over 1 minus v square by c square, and it is given x2 minus x1 is equal to 0. That is t2 dash minus t1 dash is equal to t2 minus t1 divided by square root over 1 minus v square by c square. This is equal to 9 into 10 10 power minus 6. That is 6 into 10 power minus 6 divided by 9 into 10 power minus 6 is equal to 1 minus v square by c square. Because t2 minus a1 is equal to 6 into 10 power minus 6. That is v square by c square is equal to 5 by 9. That is v is equal to square root over 5 by 3 into c. That is x2 dash minus x1 dash is equal to x2 minus x1 divided by square root over 1 minus v square by c square minus v into t2 minus t1 divided by square root over 1 minus v square by c square. So x2 minus x1 is equal to 0. So this is equal to minus v, that v into t2 minus t1 divided by square root over 1 minus v square by c square. So that is, this is equal to minus root of 5 by 3 into c, 6 into 10 power minus 6 divided by square root over 1 minus 5 by 9. So this is equal to minus 2000 meter. So this is the answer. That is the 2000 meter is the answer.
Let x comma t and x dash comma t dash be the coordinate system used by the observers O and O dash respectively. The observer O dash moves with the velocity v is equal to beta c along their common positive x-axis. If x plus is equal to x plus ct and x minus is equal to x minus ct are the linear combination of the coordinates, then the Lorentz transformation relating O and O dash takes the form dash. So here x plus is equal to x plus ct and x minus is equal to x minus ct. X plus dash is equal to x dash plus ct dash. That is equal to x minus vt divided by square root over 1 minus v square by c square plus c into t minus vx by c square divided by square root over 1 minus v square by c square. That is x plus dash is equal to x minus vt divided by square root over 1 minus beta square plus ct minus x beta divided by square root over 1 minus beta square, where beta is equal to v by c. So this is equal to x into 1 minus beta plus ct into 1 minus v by c divided by square root over 1 minus beta square. That is, this is equal to x into 1 minus beta plus ct into 1 minus beta divided by square root over 1 minus beta square. So this is equal to x plus ct into 1 minus beta divided by square root over 1 plus beta into 1 minus beta. So this is equal to x plus ct into square root over 1 minus beta divided by 1 plus beta. And we know that x plus ct is equal to x plus. So this is equal to x plus into square root over 1 minus beta divided by 1 plus beta. And we know that x minus dash is equal to x dash minus ct dash. So this is equal to x minus vt divided by square root over 1 minus v square by c square minus c into t minus vx by c square divided by square root over 1 minus v square by c square. So this is equal to x minus vt divided by square root over 1 minus beta square minus ct minus beta x divided by square root over 1 minus beta square. So this is equal to x minus vt minus ct plus beta x divided by square root over 1 minus beta square. So this is equal to x into 1 minus beta minus ct into 1 plus v by c divided by square root over 1 minus beta square. This is equal to x into 1 plus beta minus ct into 1 plus beta divided by square root over 1 minus beta square, equal to x minus ct into 1 plus beta divided by square root over 1 plus beta into 1 minus beta. This is equal to x minus into square root over 1 plus beta divided by 1 minus beta. So this is the answer. Next question is the area of a disk in its rest frame S dash is equal to 1. The disk will appear distorted to an observer O moving with the speed u with respect to S dash along the plane of disk. The area of the disk measured in the rest frame of the observer O is dash. So here it is asking about the area of the disk in the rest frame of observer. That is, here it is asking about the area of the ellipse in S frame. So in S frame, the area of the ellipse can be written as pi AB, that is equal to pi BL, because here we take A as L. And we know that as the disk is moving with respect to S frame, we can write that the length is getting contracted. So that L can be written as L naught into square root over 1 minus u square by c square. Here u is taken because the disk is moving with the speed u. So we can write the area of the ellipse as pi b L0 into square root over 1 minus u square by c square. And here pi b L0 is A0. That is, the area of the ellipse can be rewritten as A0 into square root over 1 minus u square by c square. And it is given that in S dash frame, that is in S dash frame, the area of the ellipse is 1. So that A0 is 1. Substituting this value in equation number 1, we can write the area of the ellipse in S frame as square root over 1 minus u square by c square. This is equal to 1 minus u square by c square the whole raised to 1 by 2. So this is the answer. The next question is, consider three inertial frame of reference A, B and C. The frame B moves with the velocity c by 2 with respect to A, and C moves with the velocity c by 10 with respect to B in the same direction. The velocity of C as measured in A is dash. So here VBA is equal to C by 2, VCB is equal to C by 10, VAB is equal to minus C by 2. So VCA is equal to VCB minus VAB divided by 1 minus VCB into VAB by C square. That is equal to C by 10 plus C by 2 divided by 1 minus C by 10 into minus C by 2 plus C square. This is equal to C by 10 plus C by 2 into C square divided by C square plus C square by 20. That is 2c plus 10c by 20 into c square divided by 20 c square plus c square divided by 20. This is equal to 12c by 20 into c square into 20 divided by 21 c square. This is equal to 12 by 21 c. That is equal to 4 by 7 c. So this is the answer. The next question is, a relativistic particle moves with a constant velocity v with respect to the laboratory frame. In time tau measured in the rest frame of the particle, the distance that it travels with the laboratory frame is dash. So here it is given that the particle is moving with the velocity v and h dash frame is also moving with the velocity v. So, and here x1 dash is equal to 0 and x2 dash is equal to 0. So t2 dash minus t1 dash is equal to t. Let's say tau. So x2 minus x1 is equal to x2 dash minus x1 dash divided by square root over 1 minus v square by c square divided by v into t2 dash minus t1 dash divided by square root over 1 minus v square by c square. As x2 dash minus x1 dash is equal to 0, we can write it as x2 minus x1 is equal to v into t2 dash minus t1 dash divided by square root over 1 minus v square. And we know that t2 dash minus t1 dash is equal to tau. So this is equal to v tau divided by square root over 1 minus v square by c square. So this is the answer. The next question is, a light signal travels from a point A to point B both within a glass slab that is moving with uniform velocity with speed 0.3 c with respect to an external observer. If the refractive index of the slab is 1.5, then the observer will measure the speed of the signal as dash. So here VGO, that is the velocity of glass with respect to the observer, is 0.3 c, and VLG, that is the velocity of light with respect to glass, is equal to c by n, which is equal to c by 1.5, where n is the refractive index. That is VLO is equal to VLG minus VOG divided by 1 minus VLG VOG by c square. That is equal to c by 1.5 minus of minus 0.3 c divided by 1 minus c by 1.5 into minus 0.3 c divided by c square, which is equal to 0.81 c. Next question is, two particles A and B moves with relativistic velocities of equal magnitude v but in the opposite direction along the x-axis of an inertial frame of reference. The magnitude of the velocity A as seen from the rest frame of B is dash. So here VAE is equal to V, that is the velocity of the particle A with respect to earth. This is B. So VBE is equal to minus V. So VAB is equal to VAE minus VBE divided by 1 minus VAE into VBE by C square. That is equal to V minus minus V divided by 1 plus V square by C square. This is equal to 2VC square divided by C square plus B square. So this is equal to 2VC square divided by C square into 1 plus B square by C square. That is equal to 2V divided by 1 plus B square by C square. So this is the answer. Next question is, consider a radioactive nucleus that is traveling at a speed c by 2 with respect to the lab frame. It emits gamma rays of frequency nu0 in its rest frame. There is a stationary detector in the lab. If a gamma ray photon is emitted when the nucleus is closest to the detector, its observed frequency at the detector is dash. So here the nucleus is moving with the speed of c by 2 in its rest frame. So let it be the rest frame be s dash. So here the nucleus is moving with the velocity c by 2 in the s dash frame, and it is mentioned that there is a detector but it is not in the path of the nucleus. So the detector should be placed in such a way that the nucleus and the detector should be close. So the angle that makes the detector and nucleus close is theta is equal to 90 degree. So the theta value is 90 degree here. So here f, that is the observed frequency at the detector, is equal to f0. Here f0 is the frequency of the gamma rays in its rest frame. So here f0 is equal to nu 0. So the equation is f is equal to f0 into square root over 1 minus v square by c square divided by 1 minus v cos theta by c. But here theta is equal to 90 degree. So f is equal to f0 into square root over 1 minus v square by c square. So this is equal to nu 0. So because f0 is equal to nu 0, so that this is equal to nu 0 into square root over 1 minus, and here v is equal to c by 2. So c square by 2c square. This is equal to nu 0 into root 3 by 2. So this is the answer. The next question is, a point charge is moving with a uniform velocity beta c along the positive x direction parallel to and very close to corrugated metal sheet. The wavelength of the electromagnetic radiation received by an observer along the direction of motion is dash. So here the source is moving towards the observer, so that lambda is equal to lambda 0 into square root over 1 minus beta divided by 1 plus beta. So here it is given that the lambda 0 is L. So we can write it as this is equal to L into square root over 1 minus beta divided by 1 plus beta into multiplying 1 plus beta on the numerator and denominator. We can write it as this is equal to L into square root over 1 minus beta into 1 plus beta divided by 1 plus beta into 1 plus beta. So this is equal to L into square root over 1 minus beta square divided by 1 plus beta. And we know that beta is equal to V by C. So if V by C is greater than 1, then V become greater than C. But this is not possible. So here V by C is less than 1. That is V less than C. So this is possible. So we can neglect the beta term in the denominator, so that our equation will become lambda is equal to L into square root over 1 minus beta square. So this is the answer. And here we have taken the lambda 0 value as L, because lambda 0 is the wavelength between two peaks. It is given that the wavelength between two peaks is L here, so that lambda 0 is taken as L here. So we get the answer lambda is equal to L into square root over 1 minus beta square. Next question is, what is the proper time interval between the occurrence of two events if in one inertial frame events are separated by 7.5 into 10 power 8 meter and occur 6.5 seconds apart? So here we need to find the proper time. We know that delta t is equal to delta t0 divided by square root over 1 minus v square by c square. So we need to find the proper time, that is delta t0, that is equal to delta t into square root over 1 minus v square by c square. Here it is given that delta t is equal to 6.5 seconds. So delta t0 square is equal to delta t square into 1 minus v square by c square. So this is equal to delta t square minus v square delta t square by c square. And we know that v delta t is equal to delta x. So delta t0 square is equal to delta t square minus delta x the whole square by c square. So this is equal to 6.5 the whole square minus 7.5 into 10 power 8 the whole square by 3 into 10 power 8 the whole square. So this is equal to 36. So that is delta t0 square is equal to 36. So delta t0 is equal to 6. So this 6 is the answer. The next question is, according to special theory of relativity, the speed v of a free particle of mass m and the total energy E is dash. So here we need to find the relationship between v and E. So here we know that E is equal to mc square divided by square root over 1 minus v square by c square. So squaring this, we get E square is equal to m square c raised to 4 divided by 1 minus v square by c square. So we get E square minus E square v square by c square is equal to m square c raised to 4. That is 1 minus v square by c square is equal to m square c raised to 4 by E square. So that we get v square by c square is equal to 1 minus m square c raised to 4 by E square. So that we get v is equal to c into square root over 1 minus mc by E the whole square. So this is the answer. The next question is, let V, P and E denote the speed, magnitude of momentum and the energy of a free particle of rest mass m. Then we need to find which expression is correct. We know that E square is equal to P square C square plus M0 square C raised to 4. And here M0 is equal to M, where M is the rest mass. So that we can rearrange this like this, that is by after differentiating we can write it as 2E dE is equal to 2P dP C square plus 0, because as it is rest mass it is a constant, so differentiating this we get the value 0. So that is dE by dP is equal to P by E into C square. So the relationship between dE by dP is not constant, so that option A is wrong. Then we know that P is equal to m0 v divided by square root over 1 minus v square by c square, and here m0 is equal to m, that is equal to m v divided by square root over 1 minus v square by c square. So that the option B is also wrong. Squaring this, we get p square into 1 minus v square by c square is equal to m square v square. So that p square minus p square v square by c square is equal to m square v square. That is v square into p square by c square plus m square is equal to p square. That is v is equal to pc divided by square root over p square plus m square c square. So the option C is the correct answer. Here coming to D option, we know that E is equal to m0 c square divided by square root over 1 minus v square by c square, and here m0 is equal to m, that is equal to m c square divided by square root over 1 minus v square by c square. So that option D is also wrong. So the correct answer is option C. The next question is, consider a particle of mass m moving with the speed v. If Tr denotes the relativistic kinetic energy and Tn is the non-relativistic approximation, then the value of Tr minus Tn by Tr for v is equal to 0.01 c is dash. Here we know that T non-relativistic is equal to half m naught v square and T relativistic is equal to mc square minus m0 c square. So this is equal to m0 c square divided by square root over 1 minus v square by c square minus m0 c square. So we can write Tr minus Tn by Tr is equal to 1 minus Tn by Tr. So this is equal to 1 minus half m0 v square divided by m0 c square divided by square root over 1 minus v square by c square minus m0 c square. So this is equal to 1 minus v square by 2 divided by c square divided by square root over 1 minus v square by c square minus c square. This is equal to 1 minus 0.01 the whole square c square divided by 2, because v is equal to 0.01 c. So this is written like this, divided by c square divided by square root over 1 minus 0.01 the whole square minus c square. So this is equal to 1 minus 0.01 the whole square c square by 2 divided by 1 by square root over 1 minus 0.01 the whole square minus 1 into c square. C square get cancelled, so that this is equal to 1 minus 0.01 by 2 the whole square divided by square root divided by 1 by square root over 1 minus 0.01 the whole square minus 1. So this answer is equal to 0.75. So this is the answer. Next question is, consider the decay process tau minus gives pi minus plus neutrino in the rest frame of tau minus. The masses of the tau minus, pi minus, neutrino are m tau, m pi and 0 respectively. Then what is the energy of pi minus and what is the velocity of pi minus? So we need to find the energy and the velocity value of pi minus. We know that tau minus gives pi minus plus tau neutrino.
So by applying the conservation of energy, we can write as m tau c square is equal to E pi plus E nu. This is equation number 1. We know that E pi square is equal to P square C square plus M pi square C raised to 4. This is equation number 2. And we know E nu square is equal to P square C square plus M nu square C raised to 4. And here it is given that M nu is equal to 0. So that E nu is equal to Pc. This is equation number 3. So we can write the equation number 1 as m tau c square is equal to E pi plus Pc. That is Pc is equal to m tau c square minus E pi. Substituting the value of E pi here, we can write it as m tau c square is equal to square root over P square C square plus M pi square C raised to 4 plus Pc. That is m tau c square minus Pc the whole square is equal to P square C square plus M pi square C raised to 4. That is m tau square C raised to 4 plus P square C square minus 2 m tau C square P square Pc is equal to P square C square plus M pi square C raised to 4. That is m tau square C raised to 4 minus 2 m tau C square Pc is equal to M pi square C raised to 4. That is m tau square C raised to 4 minus 2 m tau C square into m tau c square minus E pi is equal to m pi square c raised to 4. That is m tau square c raised to 4 minus 2 m tau square c raised to 4 plus 2 m tau c square E pi is equal to m pi square c raised to 4. That is minus m tau square c raised to 4 plus 2 m tau c square E pi is equal to m pi square c raised to 4. That is minus m tau square c square plus 2 m tau E pi is equal to m pi square c square. That is E pi is equal to m pi square c square plus m tau square c square divided by 2 m tau. So we can write it as E pi is equal to m pi square plus m tau square into c square divided by 2 m tau. So this is the answer. So here we get the energy of E pi like this. Now we need to find the velocity of E pi. For that we need to write the value of E pi as, we know that E pi is equal to m pi square divided by square root over 1 minus v square by c square. We also know that E pi also have the value m tau square plus m pi square into c square divided by 2 m tau. Equating these two, we can write m tau square plus m pi square into c square divided by 2 m tau, which is equal to m pi c square divided by square root over 1 minus b square by c square. So we can write square root over 1 minus b square by c square is equal to 2 m tau m pi divided by m tau square m pi square. So 1 minus v square by c square is equal to 4 m tau square m pi square divided by m tau square plus m pi square the whole square. That is v square by c square is equal to 1 minus 4 m tau square m pi square divided by m tau square plus m pi square the whole square. That is v square by c square is equal to m tau raised to 4 plus m pi raised to 4 plus 2 m tau square m pi square minus 4 m tau square m pi square divided by m tau square plus m pi square the whole square. So v square by c square is equal to m tau raised to 4 plus m pi raised to 4 minus 2 m tau square m pi square divided by m tau square plus m pi square the whole square. So that v is equal to m tau square minus m pi square divided by m tau square plus m pi square into c. So this is the velocity of pi. The next question is, the recently discovered Higgs boson at the LHC experiment has a decay mode into a photon and a Z boson. If the rest masses of Higgs and Z bosons are 125 GeV by c square and 90 GeV by c square respectively, and the decaying Higgs particle is at rest, the energy of the photon will approximately be dash. Here we need to find the value of EP, that is the energy of photon. We know that Higgs boson gives P plus Z boson. So by the conservation of energy, EH is equal to EP plus EZ. We know MP, that is the mass of photon, is equal to 0. So we can write it as m at c square is equal to
pc plus square root over p square c square plus m tau square c raised to 4. That is mh c square minus pc is equal to square root over p square c square plus m tau square c raised to 4. That is mh c square minus pc the whole square is equal to p square c square plus m tau square c raised to 4. That is mh square c raised to 4 plus p square c square minus 2 mh c square p c is equal to p square c square plus m tau square c raised to 4. That is mh square c raised to 4 minus 2 mh c square pc is equal to m tau square c raised to 4. That is mh c square the whole square minus 2 mh c square ep is equal to m tau c square the whole square. Here pc is equal to ep. So we can rewrite it as ep is equal to mh c square the whole square minus m tau c square the whole square divided by 2 mh c square. So this is equal to 125 the whole square minus 90 the whole square divided by 2 into 125. This is equal to 15625 minus 8100 divided by 250. This is equal to 30.1 giga electron volt. So this is the 30 giga electron volt is the answer. The next question is, the muon has the mass 105 MeV by c square and mean lifetime 2.2 mus in its rest frame. The mean distance traversed by a muon of energy 315 MeV before decaying is approximately dash. Here it is given that T0 is equal to 2.2 mus. We know that distance d is equal to bt. This is equal to vt0 divided by square root over 1 minus b square by c square. And we know that E is equal to 315 MeV and m0 c square which is equal to 105 MeV. So m0 is equal to 105 MeV by c square. So E is equal to 315 MeV. Substituting this values here, we get m0 c square divided by square root over 1 minus v square by c square is equal to 315 MeV. Here m0 c square is equal to 105 MeV. So that's 105 divided by square root over 1 minus v square by c square is equal to 315 MeV. So this is equal to 1 minus v square by c square is equal to 1 by 9. That is v square by c square is equal to 8 by 9. That is v is equal to square root over 8 by 3 into c. Here distance is equal to v into t. That is v t0 divided by square root over 1 minus v square by c square. That is this is equal to square root over 8 by 3 into c into 2.2 into 10 power minus 6 divided by square root over 1 minus root 8 by 3 the whole square. So this is equal to 1.86 kilometer. So this is the answer. The next question is, the energy of a free relativistic particle is E is equal to square root over p square c square plus m square c raised to 4, where m is its rest mass, p is the momentum and c is the speed of light in vacuum. The ratio Vg by Vp of the group velocity Vg of a quantum mechanical wave packet to the phase velocity Vp is dash. We know that E is equal to h cut omega, that is omega is equal to E by h, and k is equal to p by h cut, that is dk is equal to dp by h cut. We know group velocity is equal to d omega by dk. Multiplying h cut on numerator and denominator, we can write it as h cut d omega by h cut dk. That is equal to d of h cut omega by d of h cut k. This is equal to de by dp. That is Vg is equal to de by dp. And we know that Vp is equal to omega by k. This is equal to E by h cut divided by p by h cut. This is equal to E by p. So that 1 by Vp is equal to p by E and 1 by Vp square is equal to p square by E square. So E square is equal to p square c square plus m0 square c raised to 4. Differentiating this, we get 2E de by dp is equal to 2p c square. That is E by p into de by dp is equal to c square. And we know that E by P is equal to Vp and dE by dP is equal to Vg. So that Vp into Vg is equal to C square. That is Vg is equal to C square divided by Vp. That is Vg by Vp is equal to C square by Vp square. We know that 1 by Vp square is equal to P square by E square. So this is equal to C square P square by E square. So this is the answer. Next question is, a constant force F is applied to a relativistic particle of rest mass m. If the particle starts from the rest at t is equal to 0, its speed after a time t is dash. Here we need to find the velocity.
So here it is given that F is equal to dP by dt, that is P is equal to F into T. E is equal to square root over P square C square plus M naught square C raised to 4. So we also know that E is equal to M naught C square divided by square root over 1 minus V square by C square. Equating these two, we get P square C square plus M naught square C raised to 4 is equal to M naught square C raised to 4 divided by 1 minus V square by C square. Substituting the value of P here, we get Ft the whole square C square plus M naught square C raised to 4 is equal to M naught square C raised to 4 divided by 1 minus V square by C square. That is 1 minus V square by C square is equal to M naught square C raised to 4 divided by F square T square C square plus M naught square C raised to 4. That is V square by C square is equal to 1 minus M naught square C raised to 4 divided by F square T square C square plus M naught square C raised to 4. That is V square by C square is equal to F square T square C square plus M naught square C raised to 4 minus M naught square C raised to 4 divided by F square T square C square plus M naught square C raised to 4. That is V square is equal to F square T square C raised to 4 divided by F square T square C square plus M naught square C raised to 4. That is V square is equal to F square T square C square divided by F square T square plus M naught square C square. That is V is equal to FTC divided by square root over F square T square plus M naught square C square. So this is the answer. This is the velocity value after a time t. Next question is, a relativistic particle of mass m and charge E is moving in a uniform electric field of strength E. Starting from rest at t is equal to 0, how much time will it take to reach the speed c by 2? Here it is given that q is equal to E. So F is equal to QE, that is equal to E into E. That is dP by dt is equal to EE. That is P is equal to EET plus C. At t is equal to 0, V is equal to 0. So that C is equal to 0. This implies that P is equal to EE into T. So P is equal to M naught V divided by square root over 1 minus V square by C square. This is equal to EET. This is equation number 1. That is M naught divided by square root over 1 minus V square by C square is equal to M naught divided by square root over 1 minus 1 by 4. Because here V is equal to C by 2. So this is equal to M naught divided by square root over 3 by 4. This is equal to 2 by root 3 M naught. This is equal to 2 by root 3 M. Because in the option here M naught is taken as M. So substituting this value in equation number 1, equation number 1 gives 2 by root 3 MC by 2 is equal to EET. That is T is equal to MC divided by square root over 3 EE. So this is the value of time. Next question is, for a particle of energy E and momentum P, the rapidity y is defined as y is equal to 1 by 2 ln over E plus P3c divided by E minus P3c. In a frame f dash moving with velocity v is equal to 0, 0 beta c with respect to f, the rapidity y dash will be dash. Here y is equal to half into ln over E plus P3c divided by E minus P3c. And y dash is equal to 1 by 2 into ln over E dash plus P3 dash c divided by E dash minus P3 dash c. We know that x dash is equal to gamma into x minus pt. Y dash is equal to y, z dash is equal to z, t dash is equal to gamma into t minus vx by c square, E dash is equal to gamma into E minus vp, P dash is equal to gamma into P minus VE by C square. So here P3 dash is equal to gamma into P3 minus VE by C square and E dash is equal to gamma into E minus VP3. Substituting these values in y dash, we get y dash is equal to half into ln over gamma into E minus Vp3 plus gamma c into P3 minus VE by C square divided by gamma into E minus Vp3 minus gamma c into P3 minus VE by C square. This is equal to half ln over E into 1 minus Cv by C square plus P3 into C minus V divided by E into 1 plus Cv by C square plus P3 into minus V minus C. So this is equal to half of ln over E into 1 minus V by C plus P3C into 1 minus V by C divided by E into 1 plus V by C minus P3C into 1 plus V by C. we know that V by C is equal to beta. That is equal to half ln over E into 1 minus beta plus C P3 into 1 minus beta divided by E into 1 plus beta minus C P3 into 1 plus beta. So this is equal to half ln over 1 minus beta into E plus Cp3 divided by 1 plus beta into E minus Cp3. So this is equal to half ln over 1 minus beta divided by 1 plus beta plus half ln over E plus Cp3 divided by E minus Cp3. So this is equal to y plus half of ln over 1 minus beta divided by 1 plus beta, because it is given that y is equal to half ln over E plus P3c divided by E minus P3c. So this can be rewritten as this is equal to y minus ln over 1 plus beta divided by 1 minus beta. So this is the answer.
So the next question is, an inertial frame K dash moves with a constant speed v with respect to another inertial frame K along their common x direction. Let x comma ct and x dash comma ct dash denote the space-time coordinates in the frame K and K dash respectively. Which of the following space-time diagrams correctly represent the t dash axis, that is x dash is equal to 0 line, and the x dash axis, that is t dash is equal to 0 line in the xct plane? And here it is given that tan phi is equal to v by c. And so here we know that according to the Lorentz invariance, x square minus c square t square is equal to x dash square minus c square t dash square. And we know that t dash is equal to t minus v by c square x divided by square root over 1 minus v square by c square. And here it is given that for the t dash for the x dash axis, t dash is equal to 0. So if t dash is equal to 0, then t is equal to v by c square into x. So ct by x is equal to v by c, and here it is given that v by c is equal to tan phi. So this is equation number 1. So we should select such a graph that should give tan phi is equal to ct by x. So if we check the graph, if we consider this type of graph, that is x is moved by making an angle phi by covering a distance ct. In this graph, we get the value tan phi is equal to ct by x. So this satisfies our condition, equation number 1. Similarly, we have given that at the t dash axis, x dash is equal to 0. That is, we know x dash is equal to x minus vt divided by square root over 1 minus v square by c square. That is, x is equal to vt. Multiplying c numerator and denominator, we get x is equal to v by c into ct. This is equation number 2. Substituting the value of 1 in 2, we get x is equal to tan phi into ct. That is, tan phi is equal to x by ct. So the ct axis is moved by an angle phi to get ct dash in such a way that tan phi is equal to x by ct. So we get a graph like this. So combining these two graphs, we get the graph in such a way that x moving upwards to get x dash and ct axis is moving clockwise to get ct dash. So this is the answer, because this satisfies these two conditions, that is tan phi is equal to ct by x and tan phi is equal to x by ct. These two conditions is satisfied in this graph, so this graph is the answer. So option C is the right answer. Next question is, which of the following is the Lorentz invariant? So here E square minus B square is the Lorentz invariant term. Then the next question is, a rod of length L carries a total charge Q distributed uniformly. If this is observed in a frame moving with a speed V along the rod, the charge per unit length as measured by the moving observer is dash. So here lambda is equal to lambda 0 divided by square root over 1 minus v square by c square, and lambda 0 is equal to q by L. So this is equal to q by L into
square root over 1 minus v square by c square. So this is the answer. Next question is, in an inertial frame S, the magnetic vector potential in a region of space is given by A is equal to A z I cap, where A is a constant and scalar potential is 0. The electric and magnetic field seen by the inertial observer moving with a velocity vi with respect to S are respectively. So here in the S frame, A, which is the magnetic vector potential, this is equal to A z I cap, and the scalar potential phi is equal to 0. And in the S dash frame, it is moving with the velocity vi cap, and we need to find the value of E and B here. In the S frame, we know A is equal to A z I cap and B is equal to del cross A. This is equal to ijk dou by dou x dou by dou y dou by dou z a z 0 0. This is b is equal to minus j cap plus 0 minus dou by dou z of a z. This is equal to aj cap. And here we know that E is equal to minus del phi minus dou a by dou t. That is E is equal to minus 0 minus dou by dou t of aj cap. This is equal to 0. So here we understood that the value of bx is equal to 0, by is equal to a, bz is equal to 0, ex is equal to 0, ey equal to 0, ez is equal to 0. So the Lorentz transformation of E and B are, we know Ex dash is equal to Ex, Ey dash is equal to gamma into Ey minus VBZ, and Ez dash is equal to gamma into Ez plus VBZ. So here we get that Lorentz transformation is equal to Ex, this is equal to 0, and Ey dash is equal to Bx, gamma into 0 minus B by 0, this is 0, and Ez dash, this is equal to gamma into 0 plus Va, this is equal to gamma Va. So E dash is equal to gamma of Bx, By, Bz here, and we know that Bx dash is equal to 0, By dash is equal to gamma into A minus 0, this is equal to gamma A, Bz dash is equal to gamma into 0 minus V by C square into 0, that is equal to 0, that is B dash is equal to gamma A j cap. So this is the answer, that is C dash is equal to gamma Va k cap and B dash is equal to gamma A j cap. The next question is, the value of electric and magnetic field in a particular reference frame are E is equal to 3x cap plus 4y cap and B is equal to 3z cap respectively. An inertial observer moving with respect to this frame measures the magnitude of the electric field to be E dash is equal to 4. The magnitude of the magnetic field B dash measured by him is dash. Here we know that E is equal to 3x cap plus 4y cap. So the value of E is equal to square root over 3 square plus 4 square, this is equal to 5, and here B is equal to 3 z cap. So the value magnitude of B is equal to 3. Then E square minus B square is equal to E dash square minus B square, as it is Lorentz invariant. So this is 5 square minus 3 square is equal to 4 square minus B dash square, because it is given that E dash is equal to 4. That is 25 minus 9 minus 16 is equal to minus B dash square, that is B dash is equal to 0. So the magnitude of B dash measured by him is 0. So 0 is the answer. Next question is, in an inertial frame, uniform electric and magnetic field E and B are perpendicular to each other and satisfies E square minus B square is equal to 29. In another inertial frame which moves at a constant velocity with respect to the first frame, the magnetic field is 2 root 5 k cap. In the second frame, an electric field consistent with the previous observation is dash. So here B dash is equal to 2 root 5 k cap, and here E square minus B square is equal to 29. We know that E square minus B square is Lorentz invariant because it is equal in all inertial frame. That is E square minus B square is equal to E dash square minus B dash square. That is E dash square minus B dash square is equal to 29. That is E dash square is equal to 29 plus B dash square. That is equal to 29 plus 20. This is equal to 49. That is E dash is equal to 7. And it is given that E and B are perpendicular. So E dot B is equal to 0. And also E dot B is also Lorentz invariant. So E dot B is equal to E dash dot B dash is equal to 0. As E and B are perpendicular and it is given that B is in K direction, we know that E is in the I plus J direction. Then only E and B become perpendicular. That is, we should select E that has a magnitude 7 and has a direction I plus J from the option. So we have two possibilities, that is A and D has the direction I plus J. But in the D option, 7 into I plus J, if we take the magnitude, we get as E is equal to square root over 7 square plus 7 square. This is equal to root over 98. This is not equal to 7. Then coming to option A, that is 7 by root 2 into I plus j. This is equal to 7 by root 2 I cap plus 7 by root 2 j cap. Taking the magnitude, we get square root over 7 by root 2 the whole square plus 7 by root 2 the whole square. This is equal to square root over 49 by 2 plus 49 by 2. This is equal to square root over 2 into 49 by 2. This is equal to 7. So here we get the magnitude as 7 and the direction as I plus j. So the right answer is option A. Next question is, an inertial observer A at rest measures the electric and magnetic field E is equal to alpha 0 0 and B is equal to alpha 0 to alpha in a region where alpha is a constant. Another inertial observer B, moving with a constant velocity with respect to A, measures the field as E dash is equal to Ex dash alpha 0 and B dash is equal to alpha By dash alpha. Then in unit C is equal to 1. Ex dash and By dash are given respectively by dash. So here we need to find the value of Ex dash and By dash. Here we have taken two frames, that is A and B. In A frame, the electric and magnetic field is noted as E and B, and for B frame it is noted as E dash and B dash. So for frame A, E is equal to alpha 0 0, B is equal to alpha 0 2 alpha. And for frame B, E dash is equal to Ex dash alpha 0 and B dash is equal to alpha By dash alpha. We know that E dot B is Lorentz invariant. So for frame A, E dot B, this is equal to alpha square plus 0 is equal to alpha square. This is equation number 1. And for frame B, E dot B is equal to alpha Ex dash plus alpha By dash plus 0 is equal to alpha Ex dash plus alpha By dash. This is equation number 2. As it is Lorentz invariant, the equation 1 and equation 2 is equal. That is alpha square is equal to alpha into Ex dash plus alpha into By dash. That is alpha is equal to Ex dash plus By dash. This is equation number 3. As E square minus B square is Lorentz invariant, we can say that E square minus EB square is also Lorentz invariant. That is E square minus C square B square is equal to E dash square minus C square B dash square. Here it is given that C is equal to 1. That is E square minus B square is equal to E dash square minus B dash square. So for frame A, E square, this is equal to E into E, that is alpha 0 0 into alpha 0 0. This is equal to alpha square, and B square is equal to B dot B, that is equal to alpha 0 2 alpha into alpha 0 2 alpha. This is equal to alpha square plus 4 alpha square. This is equal to 5 alpha square. So we can write it as alpha square plus 0 square minus alpha square plus 0 square plus 4 alpha square, which is equal to Ex dash square plus alpha square plus 0 minus alpha square plus By dash square plus alpha square. That is alpha square minus 5 alpha square is equal to Ex dash square minus By dash square minus alpha square. That is minus 4 alpha square plus alpha square is equal to Ex dash square minus By dash square. That is minus 3 alpha square is equal to Ex dash square minus By dash square. This is equation number 4. That is minus 3 alpha square is equal to Ex dash plus By dash into Ex dash minus By dash. That is minus 3 alpha is equal to alpha into Ex dash minus By dash. That is By dash minus Ex dash is equal to 3 alpha. This is equation number 5. Adding the equation number 3 and 5, we get alpha is equal to ex dash plus by dash. 3 alpha is equal to by dash minus ex dash. This is adding these two equations, we get 4 alpha is equal to 2by dash. That is y dash is equal to 2 alpha. So we get the value of y dash as 2 alpha. Substituting the value of this in equation number 3, we get equation number 3 as alpha is equal to ex dash plus 2 alpha. That is ex dash is equal to alpha minus 2 alpha. This is minus alpha. So the value of ex dash is equal to minus alpha and by dash is equal to 2 alpha. So we get the value of E and B like this. The next question is, a heavy particle of rest mass m while moving along a positive z direction decays into two identical light particles with rest mass m where capital M greater than 2m. The maximum value of momentum that any one of the lighter particles can have in a direction perpendicular to the z direction is dash. Here the heavy particle is having the mass capital M and momentum p. It is at rest. It is decaying into two particles of mass small m. This particle is having a momentum. Taking the components of this momentum of these particles, we get P1 perpendicular, P2 perpendicular, P1 parallel, P2 parallel. P1 parallel and P1 perpendicular is the component of the momentum of particle 1, and P2 parallel and P2 perpendicular is the momentum components of particle 2. And here we know that the momentum of the heavy particle is 0 because it is at the rest position. So by the conservation of momentum, we can write 0 is equal to P1 parallel plus P2 parallel. That is P2 parallel is equal to minus P1 parallel. Taking only the magnitudes of the momentum, we can write P1 square is equal to P1 parallel square plus P2 perpendicular, P1 perpendicular square. And similarly, P2 square is equal to P2 parallel square plus P2 perpendicular square. So this can be written as this is equal to minus P1 parallel the whole square plus P2 perpendicular square. This is equal to P1 parallel square plus P2 perpendicular square. Then by the conservation of energy, EH is equal to E1 plus E2. And here we know that M1 is equal to M2. That is the mass of the two particles are equal. This is equal to M. So that we can write the energy of the two particles is same. That is E1 is equal to E2. So we can write EH is equal to 2E1. That is E1 is equal to EH by 2, which is equal to MC square by 2. And we know that E1 square is equal to P1C the whole square plus MC square the whole square. That is half MC square the whole square is equal to P1 square C square plus M square C raised to 4. That is 1 by 4 M square C raised to 4 minus M square C raised to 4 is equal to P1 square C square. That is M square by 4 minus M square the whole into C square is equal to P1 square. That is P1 is equal to C by 2 square root over M square minus 4M square. And we know that P1 square is equal to P1 parallel square plus P1 perpendicular square. For P1 perpendicular to be maximum, P1 parallel should be 0. That is P1 square is equal to P1 perpendicular square. That is P1 is equal to P1 perpendicular. To get the maximum value of P1 perpendicular, this is equal to C by 2 into square root over M square minus 4M square. Because to get the maximum value of P1 perpendicular, we know P1 parallel is 0. So that we get the value like this. This is equal to C by 2 square root over M square minus 4M square. So this is the answer. The next question is, a particle of mass 1 giga electron volt by c square and its antiparticle both moving with the same speed v produce new particle x of mass 10 giga electron volt by c square in a head-on collision. The minimum value of v required for this process is closest to dash. Here it is mentioned that it is in the head-on collision. So we can say that the particle and the antiparticle is moving in the opposite direction with the same speed. So that it is given that the mass is 1 giga electron volt by c square. So by the conservation of energy, we can write mc square divided by square root over 1 minus v square by c square plus mc square divided by square root over 1 minus v square by c square is equal to mc square. Here the capital M is equal to 10 giga electron volt by c square. So this can be solved as 2mc divided by square root over 1 minus v square by c square, which is equal to mc square, that is 2 into 1, this is equal to 10 into square root over 1 minus v square by c square, that is 1 by 25, this is equal to 1 minus v square by c square. Solving this, we get v is equal to square root over 24 by 5 into c. This is equal to 0.93 c. The next question is, a monochromatic source emitting radiation with a certain frequency moves with a velocity v away from a stationary observer A. It is moving towards another observer B along a line joining the two. The frequencies of the radiation recorded by A and B are VA and VB respectively. If the ratio VB by VA is equal to 7, then the value of V by C is dash. So here the source is moving with the velocity v from A to B. For A, the source is moving away from A. So we can write VA is equal to VA into square root over C minus V divided by C plus V. But for B, the source is moving towards B. So that VB is equal to V0 into square root over C plus V divided by C minus V. That is VB by VA is equal to C plus V divided by C minus V. This is equal to 1 plus V by C divided by 1 minus V by C. So it is given that VB by VA is equal to 7. That is 7 minus 7 V by C is equal to 1 plus V by C. That is 8 V by C is equal to 6. That is V by C is equal to 3 by 4. So the answer is 3 by 4. Next question is, an object is dropped on a cushion from a height 10 meter above it. On being hit, the cushion is depressed by 0.1 meter. Assuming that the cushion provides a constant resistive force, the deceleration of the object after hitting the cushion in terms of the acceleration due to gravity g is dash. So here we need to find the value of deceleration. We know that the object is dropped from the point A. So at that point A, the velocity, that is v1 is equal to 0. So when it is dropped from the height of 10 meter, it get reached to the point B. So at the B point, the velocity be v2. v2 square is equal to u square plus 2as, and we know that u is equal to b1, that is 0. So that v2 square is equal to 2as, that is v2 is equal to square root over 2gh. Here h is equal to 10, that is v2 is equal to square root over 20g. So here it is mentioned that when the ball is dropped, or when that object is dropped, it creates a depression of 0.1 meter. So at point C, the distance is 0.1 meter and it is deaccelerating. So that we can write A as minus A, because here minus A is used because deceleration is in the upward direction. And at C point, the velocity is 0. That is v3 is equal to 0. So we can write 0 is equal to 20g plus 2as. That is minus 20g is equal to 2 into minus a into 0.1. That is 10g is equal to 0.1a. That is a is equal to 10g divided by 0.1. That is 100g. So the answer is 100g. Next question is, a ball of mass m is dropped from a tall building with 0 initial velocity. In addition to gravity, the ball experiences a damping force of the form minus gamma v, where v is the instantaneous velocity and gamma is a constant. Given the values, m is equal to 10 kilogram, gamma is equal to 10 kilogram per second, and g is equal to 10 meter per second square. The distance traveled in meter in time, t in seconds, is dash. Here it is given that m is equal to 10 kilogram, gamma is equal to 10 kilogram per second, and g is equal to 10. So here when the ball is dropped from a height, due to its weight, the force experienced is mg. It is in the downward direction. But here it is also mentioned that there is a damping force. That is, here the damping force is acting in the upward direction as it resists the motion. So the net force is in the downward direction. That is, F net is equal to mg minus gamma v. Gamma v is the damping force. So that we can write m into dv by dt is equal to mg minus gamma v. That is, dv by dt is equal to g minus gamma v by m. That is, dv by dt plus gamma v by m is equal to g. This is in the form of dy by dx plus py is equal to q of x. So this is the linear type of equation. So that the integrating factor is e raised to integral over p dx. So the solution is y into integrating factor. This is equal to integral over q into integrating factor into dx plus c. So here the integrating factor is equal to e raised to integral over gamma by m into dt. That is equal to e raised to gamma by m into t. So the solution is v into e raised to gamma by m into t, which is equal to integral over g into e raised to gamma by m into t into dt plus c. That is, v into e raised to gamma by m is equal to g into e raised to gamma by m t divided by gamma by m plus c. This is equation number 1. At t is equal to 0, v is equal to 0. So substituting this, we get 0 is equal to mg by gamma plus c. That is, c is equal to minus mg by gamma. Substituting the value of 2 in 1, we get v e raised to gamma by m is equal to g into e raised to gamma by mt divided by gamma by m minus mg by gamma. That is, v is equal to mg by gamma into 1 minus e raised to minus gamma t by m. That is, dx by dt is equal to mg by gamma into 1 minus e raised to minus gamma t by m. That is, x is equal to integral over mg by gamma into 1 minus e raised to minus gamma by m into t into dt. That is, x is equal to mg by gamma into t plus m by gamma into e raised to minus gamma t by m plus c. That is, x is equal to 10 into 10 by 10 into t plus e raised to minus t plus c. So here we know that at x is equal to 0, at t is equal to 0, x is equal to 0. So that the equation can be rewritten as 0 is equal to 10 into 1 plus c. That is, c is equal to minus 10. Substituting this value here, we get x is equal to 10 into t plus e raised to minus t minus 10. That is 10 into t plus e raised to minus t minus 1. So this is the answer. Next question is, a cyclist weighing a total of 80 kg with the bicycle pedals at a speed of 10 meter per second. She stops pedaling at an instant which is taken to be t is equal to 0. Due to the velocity dependent frictional force, her velocity is found to be vary as v of t is equal to 10 divided by 1 plus t by 30 meter per second, where t is measured in seconds. When the velocity drops to 8 meter per second, she starts pedaling again to maintain a constant speed. The energy expended by her in 1 minute at this speed is dash. Here it is given that v of t is equal to 10 divided by 1 plus t by 30. And here a is equal to dv by dt. This is equal to 10 into d by dt of 1 plus t by 30 the whole raised to minus 1. That is equal to 10 into minus 1 into 1 plus t by 30 the whole raised to minus 2 into 1 by 30. That is, a is equal to minus 1 by 3 into 1 plus t by 30 the whole raised to minus 2. This is equation number 1. Actually, this is retardation. So when v is equal to 8 meter per second, that is 8 is equal to 10 divided by 1 plus t by 30, that is 1 plus t by 30 the whole raised to minus 1 is equal to 0.8. That is equation number 2. Substituting the value of 2 in 1, we get a is equal to minus 1 by 3 into 0.8 the whole square. That is, when v is equal to 8 meter per second, then the force is equal to ma, that is equal to 80 into minus 1 by 3 into 0.8 the whole square. This is equal to minus 17.06. So to maintain this speed, that is to maintain the speed of 8 meter per second, the cyclist must apply this amount of force. And we know that the power is equal to force into velocity, and also power is equal to work by time. So W by T, that is the work by time, which is equal to force into velocity. So here force is equal to minus 17.06 into velocity is 8. So that minus 17.06 into 8, that is the power. So the energy spent in 1 minute is power into 60. So that 17.06 into 8 into 60. So that we get 8.188 kilojoule. So this is the answer of the answer for the energy spent in 1 minute. The next question is, a particle of mass m moving along the x direction experience a damping force minus gamma v square, where gamma is a constant and v is an instantaneous speed. If the speed at t is equal to 0 is v0, the speed at time t is dash. So here a particle of mass m is moving in the x direction, and here the damping force is acting in the opposite direction, because the damping force is opposing the motion. So that here the motion is in the x direction, so it is in the, so the damping force will be in the opposite direction. So the velocity after a time t at t is equal to 0 and v is equal to 0 is, we know m into d square x by dt square is equal to minus gamma v square. This is the damping force. This is m into dv by dt is equal to minus gamma into v square. Integrating, we get integral over dv by v square is equal to integral over minus gamma by m into dt. That is minus 1 by v is equal to minus gamma t by m plus c. This is equation number 1. When t is equal to 0 and v is equal to v0, we get c is equal to minus 1 by v0. That is, we get 1 as minus 1 by v is equal to minus gamma t by m minus 1 by v0. That is 1 by v0 minus 1 by v is equal to minus gamma t by m. That is v minus v0 divided by v into v0 is equal to minus gamma t by m. That is v minus v0 by v is equal to minus gamma v0 t by m. That is 1 minus v0 by v is equal to minus gamma v0 t by m. That is v0 by v is equal to 1 plus gamma v0 t by m. That is m plus gamma v0 t by m. That is v is equal to m v0 divided by m plus gamma v0 t. So this is the answer. Next question is, a frictionless horizontal circular table is spinning with a uniform angular velocity omega about the vertical axis through its center. If a ball of radius a is placed on it at a distance r from the center of the table, its linear velocity will be dash. Here it is mentioned that the table is frictionless. Frictionless means there is no external force. That means the initial velocity and the final velocity is equal, and this is 0. So here the linear velocity is 0 because there is no force here. As there is no force, the velocity is equal and the velocity is 0 here, as there is no force here. The next question is, a turntable is rotating with a constant angular velocity omega 0. In the rotating frame fixed to a turntable, a particle moves radially outwards at a constant speed v0. The acceleration of the particle in the r theta coordinates as seen from the inertial frame, the origin of which is at the center of the turntable is dash. So here we need to find the acceleration of the particle. Here it is given that v0 is equal to a constant. That is, r dot is equal to v0. So that r double dot is equal to 0 and theta dot is omega 0 and theta double dot is 0. And we know that ar, that means the acceleration in the radial coordinates, we get ar is equal to r double dot minus r theta dot square, and a theta is equal to r theta double dot plus 2 r dot theta dot. Substituting the value of r double dot into AR equation, we get AR is equal to minus r theta dot square. We know theta dot is equal to omega 0. That is AR is equal to minus r omega 0 square. And we know A theta is equal to r theta double dot plus 2 r dot theta dot. And here r dot is equal to V0. And theta double dot is 0. So that A theta is equal to 0 plus 2 V0 omega 0. So A is equal to AR r cap plus A theta theta cap. This is equal to minus r omega 0 square r cap plus 2 V0 omega 0 theta cap. So this is the acceleration. Next question is, a solid spherical cork of radius r and specific gravity 0.5 floats on water. The cork is pushed down so that its center of mass is at distance h below the surface of water and then released. The volume of the part of cork above water level is pi r cube into 2 by 3 minus cos theta 0 plus 1 by 3 cos cube theta 0, where theta 0 is the angle as shown in the figure. At the moment of release, the dependence of the upward force on the cork on h is dash. So here the volume of the spherical cork is equal to 4 by 3 pi r cube. So the force due to this gravity Fw is equal to 4 by 3 pi r cube g into 0.5. This is equal to 2 by 3 pi r cube g in the downward direction. So by Archimedes principle, volume of the liquid displaced by cork is equal to the part of volume of cork immersed in water. So let the volume of the liquid displaced by the cork be V1, and the part of the volume of the cork immersed in water is 4 by 3 pi r cube minus pi r cube into 2 by 3 minus cos theta 0 plus 1 by 3 cos cube theta 0. Because in the question itself it is given that the volume of the cork above the water level is pi r cube into 2 by 3 minus cos theta 0 plus 1 by 3 cos cube theta 0. So the volume of the cork immersed in the water is 4 by 3 pi r cube minus pi r cube into 2 by 3 minus cos theta 0 plus 1 by 3 cos cube theta 0. So V1 is equal to 2 by 3 pi r cube plus pi r cube cos theta 0 minus pi r cube by 3 cos cube theta 0. This is equation number 1. Then from the figure we can write cos theta 0 is equal to h by r. That is V1 is equal to 2 by 3 pi r cube plus h by r minus 1 by 3 into h by r the whole cube into pi r cube. When the cork is released, so that the force is equal to Fw plus F beyond. So the F beyond force is equal to rho V1g, where rho is the density of water, which is taken as 1. That is F beyond is equal to B1g. So beyond force is equal to B1g. Here the beyond force Fb and Fw is acting in the opposite direction. That is F net is equal to Fb minus Fw. This is equation number 2. And we know that F beyond is equal to B1g, that is equal to 2 pi r cube by 3 into g plus h by r minus 1 by 3 into h by r the whole raised to 3 into g pi r cube. This is equation number 3. Substituting the value of 3 in 2, we get delta F is equal to Fb minus Fw, that is equal to h by r minus 1 by 3 into h by r the whole cube into pi r cube. That is delta F is proportional to h by r minus 1 by 3 into h by r the whole cube. So the answer is option A. The next question is, a horizontal circular platform moves with a constant angular velocity omega directed vertically upwards. A person seated at the center shoots a bullet of mass m horizontally with speed v. The acceleration of the bullet in the reference frame of the shooter is dash. So here a person is sitting in the center of the circular platform and it is moving with the velocity omega, that is equal to ohm z cap. And the person is shooting a bullet with a speed v. and here the bullet is moving outwards, so as it is radially outwards, we can say that the direction of the velocity is v is equal to v r cap. So here the Coriolis force is equal to minus 2m into omega cross v, that is equal to minus 2m omega v into z cap cross r cap. Z cap cross r cap is phi cap, that is minus 2m omega v phi cap, that is minus that is equal to 2m omega v into minus phi cap. Minus phi cap means the bullet is moving in the moving to his right. If it's plus phi cap, then it is in the left direction, but it is as it is in the minus phi cap direction, so it is in the right direction, and the acceleration is 2 omega v. So option A is the right answer. Next question is, a disk of mass m is free to rotate in a plane parallel to the xy plane with an angular velocity minus omega z cap about a massless rigid rod suspended from the roof of a stationary car. The rod is free to orient itself along any direction. The car accelerates in the positive x direction with an acceleration a greater than 0. Which of the following statements is true for the coordinates of the center of mass of the disk in the reference frame of the car? So here a disk is suspended, and it is having a velocity minus omega z cap. And here it is given that the car accelerates. As the car accelerates, it creates a pseudo force. We know that the car accelerates in the direction ax cap. So the pseudo force is in the opposite direction. So the pseudo force is minus ma I cap. When this disk oscillates, the x coordinate and the z coordinates changes. And here the r is equal to minus L into k cap. So here the torque due to the pseudo force is tau is equal to r cross f, that is minus L k cap cross minus m a I cap, that is equal to m a L j cap. J cap means the disk is moving in the y direction as the car accelerates. So here the answer is option D, because here we know that when the disk oscillates, x and z changes, and here we get that the torque is in the direction of y cap, that is in the direction of j cap. So this means that the disk is moving in the y direction as the car accelerates. That means all the three coordinates is changing. So the option D is the correct answer. The next question is, a ball of mass m initially at rest is dropped from a height of 5 meter. If the coefficient of restitution is 0.9, the speed of ball just before it hits the floor second time is approximately dash. Take g is equal to 9.8 meter per second square. So here it is mentioned that the coefficient of restitution E is equal to 0.9. Here the ball is dropped from a height of 5 meter. When it is dropped initially, the velocity is equal to 0, and after it's dropped, let the velocity be u1. Then the coefficient of restitution can be defined as the velocity of separation after collision divided by the velocity of approach before collision. That is 0.9 is equal to v1 by u1. Let it be equation number 1. We know that v square is equal to u square plus 2gh. Here initially u is equal to 0, and here when it is dropped, the velocity is u1, that is v is equal to u1. So that we can write u1 square is equal to 0 plus 2gh, that is u1 is equal to square root over 2gh. That is equation 1 implies 0.9 is equal to v1 divided by square root over 2 into 9.8 into 5, because g here written as 9.8. That is v1 is equal to 0.9 into square root over 2 into 9.8 into 5. This is equal to 8.91 meter per second. So the answer is 8.91 meter per second. Next question is, after a perfectly elastic collision of two identical balls, one of which was initially at rest, the velocity of both the balls are non-zero. The angle theta between the final velocities is dash. So here it is mentioned that among the two identical balls, one is initially at rest. So let it be. So the velocity at initially be u is equal to 0, and another ball is moving, so that it collide each other and it decays. So one particle moves with the velocity v1 and another moves with the velocity v2, making an angle theta 1 and theta 2. Taking the components of the v1 and v2, we can write v1 as v1 cos theta 1 and v1 sin theta 1, v2 as v2 cos theta 2 and v2 sin theta 2. So here the angle between the particles theta 1 plus theta 2 is equal to theta. So this is an elastic collision. So by the conservation of momentum, mu is equal to mv1 cos theta 1 plus mv2 cos theta 2. This is in the x-axis. So this is equation number 1. So here along the y-axis, 0 is equal to mv1 sin theta 1 minus mv2 sin theta 2. This is equation number 2. Then by the conservation of kinetic energy, half m u square is equal to half m v1 square plus half m v2 square. This is equation number 3. That is u square is equal to v1 square plus v2 square. This is equation number 4. 1 square, that is squaring the equation number 1 and 2 and adding, that is 1 square plus 2 square is equal to m square u square, which is equal to m v1 cos theta 1 plus m v2 cos theta 2 the whole square plus m v1 sin theta 1 minus m v2 sin theta 2 the whole square. That is u square is equal to v1 square cos square theta 1 plus v2 square cos square theta 2 plus 2v1 v2 cos theta 1 cos theta 2 plus v1 square sin square theta 1 plus v2 square sin square theta 2 minus 2v1 v2 sin theta 1 sin theta 2. This is equal to v1 square plus v2 square plus 2v1 v2 into cos theta 1 cos theta 2 minus sin theta 1 sin theta 2. This is equal to v1 square plus v2 square plus 2v1 v2 cos of theta 1 plus theta 2. Substituting the value of 4 in the above equation, we get 2v1 v2 cos of theta 1 plus theta 2 is equal to 0. That is cos of theta 1 plus theta 2 is equal to 0. That is theta 1 plus theta 2 is equal to pi by 2. That is theta is equal to pi by 2, because we know that theta 1 plus theta 2 is equal to pi by 2. So here theta is equal to pi by 2. So the answer is option A, because theta is equal to pi by 2 here. The next question is, a ball weighing 100 gram released from a height of 5 meter bounces perfectly elastically off a plate. The collision time between the ball and the plate is 0.5 seconds. The average force on the plate is approximately dash. So here it is given that the mass is 100 gram, that is 0.1 kilogram. And here by the conservation of energy, we can write mgh is equal to half mv square, that is v is equal to square root over 2gh. So here we know that the value of g is taken as 10 and h is taken as 5. That is v is equal to square root over 2 into 10 into 5. That is v is equal to 10 meter per second. That is so we get the velocity value as 10 meter per second. Then the change in momentum during this collision is, the initially we know that the ball is bouncing, so that in each bounce the ball is moving in the opposite direction. Either it moves up or it moves down. So the initial momentum and the final momentum direction is opposite. So we can say that the change in momentum is mv minus mv. That is the final value minus the initial value of the momentum. That is equal to 2 kilogram meter per second. Because here we substitute the value of v as 10 meter per second and mass as 0.1 kilogram. So here force is equal to delta P by delta T, that is equal to 2 divided by 0.5. This is equal to 4 Newton. So here we get the force as 4 Newton. The next question is, a ball initially at rest is dropped from a height h above the floor, bounces again and again vertically. If the coefficient of restitution between the ball and the floor is 0.5, the total distance travelled by the ball before it comes to rest is dash. So here we know that the ball is dropped from a height h, so it covers a distance h. Then it's bouncing upwards again and again. Then in the second bounce it covers a distance h dash. In the third bounce it covers a distance h double dash, and so on. So here the coefficient of restitution can be defined as the velocity of separation after collision divided by the velocity of approach before collision. So this is equal to v by u, and this is equal to 0.5, that is 1 by 2. So here we can write v by u is equal to 1 by 2, that is v is equal to u by 2. Then we need to check the distance covered. So here the ball is dropped from a height. So here the in the distance the s is equal to h plus h dash plus h dash plus h double dash plus h double dash plus etc. plus infinity. Here h dash is written 2 times and h double dash is also written 2 times, because here in the first bounce it covers a distance h, and in the second bounce it moves upwards covering a distance h dash, and it moves downwards by covering the same distance h dash. Then in the third bounce it covers a distance h double dash and moves upwards, and then comes to downwards, always covering the h double dash, so that in the distance h dash and h double dash comes 2 times. That is s is equal to h plus h dash plus h dash plus h double dash plus h double dash plus etc. plus infinity. That is s is equal to h plus 2h dash plus 2h double dash plus 2h triple dash plus etc. plus infinity. This is equation number 1. And we can also write the coefficient of restitution as E is equal to square root over h dash by h, where h dash is the height that is covered in the second bounce and h is the height that is covered in the first bounce. So here it is given that E is equal to 1 by 2. This is equal to square root over h dash by h. So we can write h dash is equal to h by 4. Similarly, we can write E is equal to half. This is equal to square root over h double dash by h by 4, because E is defined as the square root over the height of the next bounce divided by the height of the previous bounce, so that it is written like this. That is h double dash can be written as 1 by 4 into h by 4 is equal to h by 60. Similarly, we can write h triple dash as h by 64. So the equation 1 can be rewritten as s is equal to h plus 2h by 4 plus 2 into h by 16 plus 2 into h by 64 plus etc. plus infinity. That is s is equal to h plus h by 2 plus h by 8 plus h by 32 plus etc. plus infinity. That is h plus h into 1 by 2 plus 1 by 8 plus 1 by 32 plus etc. plus infinity. So here we know that the common ratio r is equal to 1 by 8 divided by 1 by 2. This is equal to 1 by 4. So The sum of the terms S infinity is equal to A divided by 1 minus R, where A is the first term, which is equal to 1 by 2 divided by 1 minus the common ratio, that is 1 by 4, that is 1 minus 1 by 4. So this is equal to 1 by 2 into 4 by 3. This is equal to 2 by 3. So this is so substituting the value of 2 by 3 here as the sum of this series. So we can write this as h plus h into 2 by 3. This is equal to 5h by 3. So the answer is 5h by 3.
This is the end of this video. Thanks for watching this channel.